Okay, students, welcome back. So in the earlier video, I have discussed about balancing of chemical reaction and what are the properties which are shown by any chemicals, any kind of chemical reactions which are going on. So in this video, I'll be discussing about the types of chemical reactions as given in your NCERT course for class 10. Now, first of all, we have combination reaction. So from the name itself, we can come to know combination reaction is what? Where two or more simple substances will combine and it will form a complex product. So that is called combination reaction. The first example that is given here is quicklime and water. Quicklime, I told you earlier, it is your dry lime. सूखा चूना जो होता है हुकन सून हे तो तुम्हें पानी दी दिया. If we take dry lime and put that in water, what will happen? There will be rapid bubbling and that will result in formation of the wet lime, which is called slake lime. So what is the combination taking place here between calcium oxide and water? So this is a highly exothermic reaction because a lot of heat is also released as well. Other examples are there. So a continuation of that process, that slake lime that you will get, suppose you have mixed in a beaker, you have taken water and you have put some pieces of quicklime, so it will form slake lime. After some time the slake lime will settle down and on top you will get a clear solution. Now this is your slake lime and on top the clear water is called lime water. It is called lime water. Now the formula of lime water is also same as that of slake lime. It is your calcium hydroxide. So we have this reaction. Now how do we test? Now this reaction that you can see, this is a way of testing the presence of carbon dioxide. Carbon dioxide is a colorless gas. So if I give you a container containing carbon dioxide, how will you confirm that it is carbon dioxide? What we do, we pass that carbon dioxide through lime water. If we pass it through lime water, what we will get? We'll end up getting calcium carbonate. So the lime water will become milky. So normally lime water is transparent, but if you pass carbon dioxide through it, you can take a straw and blow bubbles into it. You'll find that it becomes milky due to formation of calcium carbonate. Calcium carbonate, you can see S is written. That means it is solid in nature. It does not dissolve in water. So these are examples of combination reaction. Other examples that I can show you here. First one is, see, carbon plus oxygen. Suppose you are burning coal. You've seen burning of coal. So carbon is coal and plus oxygen. Burning means reacting with oxygen. So it will end up forming carbon dioxide gas. Similarly, hydrogen. Suppose hydrogen gas, if you burn it, I told you that it will burn with a blue flame and pop sound. It will give you water plus heat. So in both the reactions, both are combination reaction, no doubt, but in both the reaction along they are combining with oxygen and there is release of heat and light. So in both the reaction, heat and light is being formed. So such kind of combination reaction where heat and light are produced, they are also called combustion reactions. So what we can say, listen very carefully, all combination reactions may not be combustion reaction because heat and light is not produced everywhere, but all combustion reactions are combination reaction. For example, like when we are having our food is getting digested. You know, in respiration what happens? Glucose is oxidized, but only heat is formed, light is not formed. So that means there also combination is going on, but that's not a combustion reaction. So these are the different examples of combination reaction. Next we come to decomposition reaction. So in decomposition reaction, as the name indicates, decomposition means what? Breakdown. So a complex substance will break down into simpler substances. So what are the different examples given here? The first example that you can see is the decomposition of ferrous sulfate. Now ferrous sulfate are green, pale green color crystalline salt. Okay. Now The formula for those pale green color crystalline salt is FeSO4.7H2O. So that means with one molecule of FeSO4, 7 molecules of water remain attached. So these are hydrated salt. What kind of salt? Hydrated, having water molecules. Now if you take that ferrous sulfate, green color ferrous sulfate, and you heat it, in the test tube you will find, you can see the diagram is given here. When you are heating ferrous sulfate crystals, on the cooler side of the test you will find lots of water drops are being formed. Why? Because this ferrous sulfate will decompose and it will give you dry ferrous sulfate, and the water molecules will get separated. Now that dry ferrous sulfate, or it is also called anhydrous, without water, it is what in color? Dirty white. So green color ferrous sulfate becomes dirty white. Now you go on heating it. So there is one decomposition. The water has got decomposed, it has come out. Now the dry ferrous sulfate, you go on heating it. After some time you will find that the salt becomes brown in color because it gets broken into ferric oxide, and some gases will be released, colorless gas. Remember, if you smell that gas, it will give you a pungent smell. Pungent means very suffocating smell. Why? Because of these two gases, sulfur dioxide and sulfur trioxide. They give you a very suffocating effect. You will start kind of coughing. So that is another example of decomposition reaction. Another example which is there in your book, lead nitrate. You will be doing it in your practicals as well. It's a white color salt, normal, just like the normal salt we have at home. So like that, you take lead nitrate salt in a dry test tube and you heat it. What you will hear is crackling sound, as if you will get the feeling as if the glass is cracking, and slowly reddish brown some gases will come out. So these reddish brown gases, fumes, is of which gas? It is of nitrogen dioxide, and along with that oxygen gases also evolved. And this white color lead nitrate, it will change into yellow color. This is yellow color lead oxide. Now what happens here? So how will you come to know that the gas is nitrogen dioxide? Because it is reddish brown in color. And another gas is coming out, oxygen. How do you know that that gas is oxygen? Because if you bring a burning matchstick, oxygen is a supporter of combustion. If you bring a burning matchstick, what will happen? The flame will become bigger. So that is the proof of oxygen. So all these reactions are occurring by supplying heat. Therefore, they are called thermal decomposition. So decomposition reactions are of different types depending on the source of energy we are providing. So all these are thermal decomposition. Next, decomposition can also take place by passing electric current. So that we will see in the example of electrolysis of water. Suppose in a beaker we take water, there are two electrodes and we pass current. So after some time you will find that bubbles are coming out. So there is the positive electrode, it is called the anode, and there is the negative electrode, it is called the cathode. Now question is, in which electrode which gas will be released? So if we take, suppose we take water and we are passing electricity through it, initially it will break into hydrogen ion and hydroxyl ion, not into hydrogen and oxygen, hydrogen ion and hydroxyl ion. So this is a positive ion, so it will go towards the negative electrode. So hydrogen ion, it will come towards the negative electrode. So at cathode, what happens? The cation will go, this is the cation. So hydrogen will come. So hydrogen H plus means it is having one electron less, and this is negative electrode means it is having lots of electrons. So this hydrogen ion which is having one electron less, it will gain one electron and it will become hydrogen atom. So two such hydrogen atom will combine together to form hydrogen gas. What happens at anode? So at anode what is going? Hydroxyl ion will go, OH ion, it will be traveling towards the anode. So at anode, anode is positively charged, that means it is having less electrons. So at anode it will lose one electron. One electron will be lost from here. So it will become OH. So like that, there are many OH. So OH will react with another OH present, and they will combine to give you a molecule. Look at the underlined part. It will give you a molecule of water, which will go back into the solution, and you will get one oxygen atom. So just like 2 OH gave you 1 O, similarly another 2 OH will combine, and similarly you will end up getting what? Water plus O. So this O and this O will combine to give you O2. So ultimately here the bubbles are of which gas? It is of oxygen gas. And here the bubbles are of which gas? Hydrogen gas. Okay. So one question comes very often that here at one of the electrode the amount of gas produced is more compared to other electrode. If we try to simply explain it, look at the formula of water, H2O. So by volume also hydrogen is double the volume, so the amount of gas evolved at the cathode will be double. Hydrogen will be double the amount compared to that of oxygen. So this is your electrolytic decomposition. Then we have decomposition occurring with the help of sunlight as well. So if we look here, suppose we take silver chloride. Silver chloride is a white color salt, and if you expose silver chloride to sunlight, the white color salt will become gray. Why it will become gray? Because it decomposes to give you silver, and along with that chlorine gas is evolved. Similarly, silver bromide, it is light yellow salt. If you expose it to sunlight, it will give you silver and bromine. Now this particular reaction, it was used in early times black and white photography. In early times black and white photography, they had some plates, photography plates, and in those photography plates there was a layer of silver chloride, and when they opened the shutter, the layer got exposed to sunlight and the decomposition took place and the photograph developed. So the use of this was in black and white photography. There is one more interesting example of thermal decomposition. So this is photolytic decomposition, because the decomposition is occurring with the help of sunlight or light. Then calcium carbonate, decomposition of calcium carbonate. Now why this is interesting? Because there is a substance which you see quite often, calcium carbonate. It is called marble or chalk, the normal chalk we used to write on the blackboard. So you take some chalk, crush it, heat it in a pan. You can do it at home also. You will find that after some time you are starting to get the smell of lime. Sooner smell to arambho koriba. So that means your chalk has got converted into lime, and what gas is coming out? Carbon dioxide is coming out. So how do you test carbon dioxide? One, though, you can pass it through lime water will become milky, or you can do one thing, you take a burning mastic and you bring it near the pan or near the mouth of the test tube. The flame will get extinguished. So that is another test for carbon dioxide. Next we come to displacement reaction. So displacement reaction, you know that there is a series which is called the reactivity series. Reactivity series begins with the most reactive element, potassium. So there are other elements as well, but for your level this will do: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, silver, gold, platinum. In between there is hydrogen as well. So you'll be getting hydrogen in between. So when we are talking about displacement reaction, it means a more reactive substance will displace a lesser reactive substance from its solution. The most common example is reaction between iron and copper sulfate. So copper sulfate solution is blue in color. You can see the diagram here. So what you can do, you make a copper sulfate solution and you dip an iron nail. So after some time, around the iron nail, some reddish brown deposits will be formed, and this blue color solution will turn into pale green. What is the reason? Iron is more reactive than copper, so iron will be displacing this copper. So this is an example of displacement reaction. Similarly, here also you have different reactions: zinc plus ferrous sulfate, zinc plus lead nitrate, lead plus copper chloride, copper plus silver nitrate. So all these are different kind of your displacement reaction. Like ferrous sulfate is green in color, but when it will become zinc sulfate, it is colorless. But if you do the reverse reaction, suppose you have taken a solution of zinc sulfate and you have put iron nail into it, there will be no reaction. So you have to be careful when questions comes in exam. You have to know the reactivity series. Okay, so it's always not that the reaction is occurring between metals only. Non-metals may also be involved. Like for example, suppose zinc is added to sulfuric acid, dilute sulfuric acid. So what zinc will do? Zinc is more reactive than hydrogen, so zinc will displace this hydrogen and you will get zinc sulfate, and bubbling will take place of hydrogen gas. And you know how to test the gas? You bring a burning mastic or a splinter near the bubbles or near the gas will burn with a blue flame and pop sound. Similarly, the fourth type of reaction that we have is double displacement reaction. So double displacement reaction is actually mutual exchange of substances or ions between two reacting compounds. This example, like barium chloride and sodium sulfate. So barium chloride and sodium sulfate both are colorless solution. Now when you will mix them, you will get a white milky precipitate. Why? Because barium will come in place of sodium and sodium will go in place of barium. So you end up getting barium sulfate and sodium chloride. So barium sulfate is a white precipitate. So like that, we have different types of double displacement reaction. So what is double displacement reaction? Where there is mutual exchange of ions taking place. So this example that you can see here, this is a reaction between sodium carbonate and hydrochloric acid. So when there is a reaction between sodium carbonate and hydrochloric acid, sodium chloride is formed and along with that carbonic acid will be formed. So there is also a double displacement reaction. I'll be discussing this matter later on. In the next video, we'll be discussing about oxidation and reduction reaction. Then we'll discuss that. Now, you must have heard about neutralization reaction. So this is an example of neutralization reaction. So neutralization reaction means reaction between an acid and a base. So all acids have hydrogen in common, all bases have hydroxyl ion in common, OH. So when you react an acid with a base, this H from acid and OH from base will combine. H and OH will combine and they will end up forming what? Water. And this positive ion from the base and the negative ion from the acid, sodium and chloride ion, they will combine to form the salt. So all kind of neutralization reaction are nothing but double displacement reaction. Reaction between an acid and base giving you salt and water. Is that clear? So these are some very interesting reactions that I have discussed, the 4 types of reaction. So you will pause the video in between, note down the equations and you will try to understand and do put forward your queries. This thing also I am focusing here. You read this part, try to understand. I'll discuss that in the next video along with oxidation and reduction reactions.